Hi, in this video we will be learning what is expectation. So let x be a discrete random variable which takes value values x1, x2 all up to xn with corresponding probabilities fx1, fx2 all up to fxn. Then the formula for expectation of x is given by x1 f of x1 plus x2 f of x2 all up to xn f of xn. If we generalize, it's nothing but summation I is equal to 1 to n, because we have n number of observations, xi into f xi, which is also written as simply x fx, notations only. Now write down the remarks. Above we have seen it was a discrete case, but what happens if it is a continuous case? The formula will be for expectation x is equal to minus infinity to infinity x fx dx. Since it's a continuous random variable, we cannot add them, we can integrate them. That's the whole idea, which can also just notation only, x f of x dx. Second remark, expectation x is the mean of probability distribution. Let me take you to your 11th or 12th class when statistics was taught. You remember there was something called group data, ungrouped data, ungrouped data. In ungrouped data, we used to do simply sum of observation upon total number of observation. In the group data, what we used to do, there was a direct method, and the direct method's formula was x bar is equal to summation fi, where fi is frequency, xi upon summation fi. Summation fi is total number of observations, total number of frequencies rather. So similarly here this will become, if we just open it, fi xi plus f2 x2 xn xn fn divided by, I am representing it by n, summation total number of frequencies. So if I write x1 f1 by n plus x2 f2 by n xn fn by n, if you see carefully, it is nothing but frequency upon total number of frequencies. So this is probability only, x1 by p1 plus x2 into p2 plus xn into pn. So, and this is nothing but expectation of x only. So x bar is equal to expectation of x. Third remark, expectation is also identified with population mean, with population mean mu, that is expectation of x is equal to mu. And the fourth observation is expectation xn is equal to summation xn f of x when it is discrete. Summation no, sorry, xn, this is n, xn f of x dx when it is continuous. See, the basic idea is, let's say if you have x, a random variable taking 0, 1, 2, and the probability is 1 by 4, 1 by half, 1 by 4, and if you take x square, then it will be 0, 1, 4. Although this has changed, but the probability has remained same. That's the whole idea. Let's take an example. Let x be a discrete random variable having probability distribution function f of x is equal to 1 upon x, x plus 1, if x is equal to 1 to infinity, 0 otherwise, which means whenever x is not taking values, uh, whenever x is not taking 1, 2, 3 all up to infinity, it is 0. So how to solve it? Since it's a discrete random variable and we know formula for finding expectation, it's summation x into fx. So it is nothing but summation x. In place of f of x, we can replace x plus 1. So x will get cancelled out and we will be left with 1 upon x plus 1. So it is nothing but 1 upon 1 plus 1 plus 1 upon 2 plus 1 plus 1 upon n plus 1, and it will keep on going and it will come out to be infinity. So here expectation does not exist since expectation can't be negative. Let's take another example. Let's say we have a random variable. This time it is a continuous random variable. It's 2x if x belongs to 0 to 1. So this is a way we can identify whether it's a continuous or discontinuous. Continuous are always in interval, 0 otherwise. That means whenever x is not taking values between 0 and 1, it is always 0. That's it. So what is the formula for expectation of x? It's, since we have our limit 0 to 1, x f of x. So it is nothing but 0 to 1 x 2x dx. Here also we have dx. So it will come out to be what? 2 is 2 is constant, x square by 2, 0 to 1. And when we will take the limit, sorry, it's x cube, since x square, and this will come out to be 3. So 2 by 3, 1 cube minus 0 cube, so it will come out to be 2 by 3. Let's talk about of properties of expectation. The first property is expectation of a is equal to a. How to prove? Basically, where a is constant, expectation of any constant is constant itself. So proof, expectation of A is equal to mean of A, and we know from our school days, divided by n, where A is n times. So if we sum all the A's, then it will come out to be NA, and this will get cancelled out, and expectation of A is nothing but A only. This is our first property. Then we have our second property, expectation AX plus B is equal to A expectation X plus B, where A and B are constants. So let's prove LHS. I'm taking AX plus B is equal to summation X A AX plus B into f of x. This can be written as Ax f of x. I'm just multiplying inside the bracket, plus summation x b f of x. Then constant can be taken out of the summation, x f of x. Similarly here, b can be taken out, f of x. And we know for PDF to be defined, it has to be equal to 1. So this will be nothing but only b into 1, and this is nothing but expectation of x. And we had in our RHS expectation Ax plus B, hence proved. This is our second property. Third property we have expectation of x is E of x. Proof. We have seen in our remarks that we can write expectation of x is equal to mu, and mu is a constant, and we know from the first property mean of a constant is constant only, hence expectation x. This can be written as expectation mu. This is nothing but mu. This is nothing but E of x. Now fourth property, expectation x minus mu is equal to 0. Proof. Expectation x minus expectation mu. I am taking RHS. Oh, sorry, LHS. So this implies expectation of x, we have seen it's mu, and expectation of mu is mu only, hence this will come out to be 0. Now fifth property, expectation g of x is equal to g E of x, where g of x is linear. Proof. Let g of x is equal to Ax plus b. Now for LHS, expectation g of x will come out to be expectation Ax plus b, and we have seen in the above properties it will come out to be E of Ex plus b. For RHS, let's g of x is nothing but ax plus b. Now sorry, g expectation of x will be a expectation of x plus b, and LHS and RHS are same. See, what we have done is simply, if you put some value say p here, then x will get replaced by p, a constant number. Similarly, when we have replaced x with expectation of x, x got replaced by expectation of x. Now sixth property, if x and y are independent, then we are claiming exy is expectation of x into expectation of y. Let us prove it. It's a nice proof. So expectation exy can be written as summation. It's a bivariate. We are getting into bivariate. Y x y f x comma y. Now since we are saying x and y are independent, so this can be written as f of x into f of y. Correct? So further I can take in this x f of x y y into f of y. And if you observe it carefully, this is nothing but expectation of x into expectation of y. Hence proved. It's a simple proof. Now seventh property. If x and y are two random variable, then we are claiming expectation of ex plus y is nothing but expectation of x plus expectation of y. Let us prove it. So we are taking LHS. Expectation of x plus y can be written as x y x plus y f x comma y. Since it has not been mentioned that it is independent, we won't be breaking it. Let us solve it. X y, we are simply multiplying it inside the bracket. Now observe it carefully. This is what and this is what? This is marginal probability of x and this is marginal probability of y. So this will come out to be x f of x plus y y into f of y. So this is nothing but expectation x plus expectation y. So here we are done with the properties. Let me take you what we few common mistakes. Common mistakes. This is related to property number 5 mainly. The first one, expectation 1 upon x is not equal to 1 upon expectation x. Be careful. Let me give you an example. Let's say x is following uniform distribution from 1 to 3. Then we know the PDF will be, this is nothing a b, so b minus a, so 1 by 2. So expectation of x will be a plus b by 2, so this will come out to be 2. Now expectation for 1 by x, this will be 1 to 3, 1 upon x, and we have f of x is 1 by 2 into dx. So this will come out to be 1 by x is log, and when we will be taking the limit log 3 minus log 1 is 0 only. So this will come out to be log 3 by 2, and these two are not equal. Second common mistake. expectation x square is not equal to expectation x whole square. Let me give you an example, counter example rather, I should be saying. Let's say we have our x values -3, 6, 9. And the probability is given as 1 by 6, 1 by 2, 1 by 3. Now, let's say we want to find expectation of 2x plus 1 whole square. Then this will come out to be nothing but 4x square plus 1 plus 4x. So this will come out to be 4ex square plus expectation of 1 is we know 1 only, and 4e of x. Now let us find expectation x square. So this will come out to be summation x square f of x. This is nothing but -3 whole square into 1 by 6 plus 6 square into 1 by 2 plus 9 square into 1 by 3, which will come out to be 93 by 2. Expectation of x will be summation x into f of x, which will come out to be -3 into 1 by 6, 6 into 1 by 2 plus 9 into 1 by 3. So this will come out to be 11 by 2. And when we will substitute the values for the ex square and ex, we will be getting the value 209. Keep this in head. This is 209. Now let me use another pen. Now let's check what will happen if I take 2x plus 1 and I want to take the whole square of this. So this will come out to be what? This will come out to be 2 expectation of x plus expectation of 1 is 1 only whole square. So when I substitute the value for e of x, then it will come out to be what? 11 by 2, 2 get cancelled out. 11 plus 1, 12. 12 ka whole square is 144. And this is definitely not equal to 209. Hence, the claim which I made, expectation of x square is not equal to expectation ex whole square. The third and the last claim or the mistake which I am making, which a student often make, is expectation log of x is not equal to log expectation x. Reason being, log x is not a linear function. Property number 5 is valid only when g of x is linear. Let me give you an example. Let's say x is a random variable which is taking two values, 1 or 100, with equal probability, 1/2. Then expectation of x is nothing but half into 1 plus half into 100, which is nothing but 50.5. Now log, if I take log of expectation of x, then log of 50.5, which will come out to be approximately 3.92. Now if I take expectation of log of x, then what will happen? Half into log 1, log 1 is nothing but 0, plus half into log 100, log 100 is nothing but 2. So this will come out to be 1. So 1 is definitely not equal to 3.92. Hence, these all are the mistakes. I hope you like this video.